PC building mistakes can be surprisingly expensive. Some waste a few extra bucks. Others burn through hundreds in lost performance or hardware you'll replace way sooner than you expected. The worst part is most of these feel like smart decisions when you're making them. Here's every common PC buying mistake, what it actually costs you, and how to avoid each one. Buying a CPU for the wrong tasks. Dropping most of your budget on a top-tier Core i9 or Ryzen 9 strictly for gaming is one of the fastest ways to ruin your build's price-to-performance ratio. Modern games lean heavily on the graphics card. The CPU mostly handles game logic and physics while feeding frame data to the GPU. A flagship processor paired with a mid-range graphics card means the chip idles at 20% utilization while the GPU chokes on every frame. For a pure gaming rig, a solid mid-range CPU handles frame delivery just fine. Take that $100 difference and funnel it directly into a better GPU tier. You'll get noticeably higher frame rates from the same total budget. Now, if you're doing heavy video editing or 3D rendering, that's where a high core count CPU actually earns its price tag. But for gaming alone, mid-range is the sweet spot. Cost of mistake, $100 wasted on processing power that never gets used. Underpowered CPU coolers. Pairing a high-end processor with a tiny bundled cooler is asking for immediate problems. Modern CPUs are designed to push themselves right up to their thermal ceiling. Most target around 90 degrees Celsius under load. If the cooler can't pull that heat away fast enough, the chip protects itself by dropping clock speeds. That's thermal throttling. You paid for full performance, and you're only getting about 80% of it within 3 minutes of launching a game. Meanwhile, the fan is running at max RPM, screaming the entire time. The fix isn't complicated. A decent tower cooler runs about $30 to $40 and handles most processors without breaking a sweat. For the high-end chips that push 200 watts or more, a 240mm liquid cooler in the $60 range keeps things quiet and cool. Either way, skimping on cooling is paying full price for a CPU and then voluntarily giving back a chunk of its performance. Cost of mistake. Zero up front, but a permanent 20% loss in processing power. Underpowered motherboard VRMS. Sticking a power-hungry flagship processor onto the cheapest entry-level motherboard creates a bottleneck most people never even think about. The VRMs, voltage regulator modules, are the small components clustered around the CPU socket. Their job is delivering clean, stable power. On cheap boards, these VRMs use fewer phases and smaller components that overheat under sustained load. When that happens, the motherboard forces the CPU to pull less power and drop its clock speeds. Doesn't matter if your CPU cooler is working perfectly. The chip is getting strangled at power delivery level, not the thermal level. Under sustained all-core workloads like rendering or compiling, you can lose a shocking amount of performance. Cost of mistake. You saved $50 on the board, but lost up to half your CPU's real-world output. Overpowered GPUs for 1080p gaming. Buying a flagship GPU like an RTX 5090 and plugging it into a system with a basic 1080p 60Hz monitor creates a bottleneck going the wrong direction. At 1080p, the workload per frame is relatively light. The GPU tears through each frame almost instantly and then waits for the CPU to deliver the next batch of data. That expensive card ends up sitting around 50% utilization while the CPU maxes out at 100%. You're paying for a graphics card that's literally bored. Unless the goal is competitive esports at absurd frame rates, like 400 or 500 FPS, there is no visual payoff. The monitor can't display the difference anyway. Pairing a flagship GPU with a 1080p panel is burning cash for performance you'll never actually see on screen. Cost of mistake. $300 overpaid for raw GPU power trapped behind a resolution ceiling. Weak GPS for 4K pieces. The opposite problem. A beautiful 4K monitor paired with a budget or lower mid-range graphics card makes modern gaming genuinely unplayable. 4K resolution means rendering 4 times the number of pixels compared to 1080p. That's an enormous jump in GPU workload. A weak card will struggle to hold a stable 30 FPS in recent titles, even with every visual setting dragged down to minimum. And the obvious workaround, running games at 1080p on a 4K panel, doesn't actually help. Because 1080p doesn't scale cleanly into a 4K pixel grid, the image ends up soft and smeared. You're left choosing between a choppy slideshow at native resolution or a blurry mess at a lower one. Neither is what you paid for. Cost of mistake, a 20 FPS experience or a blurry upscaled image that defeats the entire point of buying a 4K display. Choosing cases solely on aesthetics. Picking a PC case because it looked stunning in a product photo without actually checking the physical dimensions is a classic first build mistake. Modern graphics cards have gotten enormous. Many flagship cards exceed 300 millimeters in length and occupy 3 full expansion slots. Some of the latest models are practically bricks. Budget cases, compact cases, and even some mid-towers simply cannot fit these cards. Others technically fit the GPU, but leave zero clearance for a front-mounted radiator or proper cable management. Overlooking maximum CPU cooler height or motherboard form factor support is another version of this. You get all your parts, start building, and realize the side panel won't close. Or the standoffs don't line up. Cost of mistake, returning a big metal box, eating the return shipping cost, and pushing your entire build back by a week or more. Populating 4 slots of DDR5 memory. Filling all 4 DDR5 slots on the motherboard seems like the obvious move. More RAM sticks, more memory, better performance. But the memory controller on modern consumer CPUs struggles with 4 high-speed DDR5 modules running simultaneously. The electrical load is too heavy. To keep the system from crashing, the motherboard automatically reduces memory speed. A kit rated for 6,000 MHz might drop to 4,800 MHz, or even lower when all 4 slots are populated. That's a significant hit to memory bandwidth. For DDR5 systems, 2 sticks is the configuration that actually lets you reach advertised speeds. If you need 64 GB, buy a single 2-stick 64 GB kit rather than filling all 4 slots. Cost of mistake, 0 extra spent, but you lose around 20% of your memory bandwidth and open the door to random system crashes. Mixing different RAM kits. Buying 2 separate RAM kits, even if they share the exact same brand and model number, same speed rating, is a gamble that frequently backfires. Memory manufacturers regularly swap the underlying silicon inside their products without changing the external packaging or model name. One kit you bought in January might use Hynix memory chips. The identical-looking box purchased in March might contain Samsung dies. Mixing different silicon on the same motherboard makes it extremely difficult for the memory controller to lock down stable timings. The system might boot fine at first, then crash under load, then refuse to boot at all until you reset the BIOS. Cost of mistake, random blue screens and failed boots. Hours of troubleshooting a problem that looks like it shouldn't exist because the boxes match perfectly. Gen 5 SSDs for or pure gaming. Paying a hefty premium for a PCIe Gen 5 NVMe drive just for a gaming system is money thrown away. The sequential read and write numbers look spectacular on the spec sheet. Marketing loves those numbers. But games predominantly use random reads, not large sequential transfers. In real-world side-by-side game loading tests, a Gen 5 drive loads levels and assets almost identically to a quality Gen 4 drive. The difference is measured in fractions of a second, if it's measurable at all. On top of that, Gen 5 drives generate significantly more heat and require bulky dedicated heatsinks that can block other components or interfere with airflow. All that thermal headache for zero gameplay benefit. Cost of mistake, $100 extra for literally 0 seconds saved on any loading screen you'll ever see. QLC SSDs for heavy write, work nods. Choosing a cheap QLC-based SSD for a workstation used for video editing or large file transfers is a decision that will haunt you during every render. QLC, quad-level cell, stores 4 bits per memory cell instead of 3. That lowers manufacturing costs, which is why QLC drives are cheaper. But the trade-off is brutal during sustained writes. Every QLC drive has a fast SLC cache that handles short bursts well. Once a long write fills that cache, transfer speeds fall off a cliff. Some QLC drives drop to speeds slower than a traditional spinning hard drive, and the more data already on the drive, the smaller the available cache, and the faster this collapse happens. For any workload involving large sustained writes, spending a bit more on a TLC drive is not optional, it's mandatory. Cost mistake: agonizingly slow transfer speeds during renders and a measurably shorter drive lifespan. Cheap and underpowered power supplies. Treating the PSU as the part where you save money is the single most dangerous mistake on this entire list. It's the one component that can physically destroy everything else. Modern GPUs and CPUs pull power in short, violent spikes. A high-end GPU can momentarily draw double its rated wattage for a fraction of a second. Cheap, unbranded power supplies lack the high-grade capacitors and internal filtering needed to absorb those spikes. They're also missing the safety circuitry that prevents catastrophic failures. When a bottom-tier unit fails, it almost never dies quietly. A blown PSU can send a high-voltage surge straight through the power cables, frying the motherboard and GPU in a single pop. Sometimes the CPU goes with them. I've seen it happen. Everything dead. No recovery. Cost of mistake: the total destruction of a $2,000 system. Because someone saved $20 on the one part that feeds electricity to everything. Buying used parts without verification. Purchasing pre-owned hardware from online marketplaces without a transferable warranty or any way to verify condition is a serious financial gamble. Graphics cards pulled from mining operations often have degraded VRAM and completely dried out thermal paste. They'll show normal temperatures at idle and then instantly overheat the moment any real game load hits. CPUs from unknown sources can have bent pins or damaged integrated heat spreaders that aren't visible in listing photos. Without physically watching the component pass a proper stress test in front of you, you're betting money on a part that might crash 30 seconds into its first real workload. And once a marketplace seller stops responding, which many do, you're stuck. Cost of mistake: hundreds of dollars lost on dying hardware with absolutely no warranty protection. Those are the 12 biggest PC building mistakes people keep making. Some of them are obvious in hindsight. Most of them aren't obvious until it's too late. If this video saved you from even one bad decision, drop a like and subscribe for more PC guides. I also made other videos covering specific builds and part picks. Go check those out too. Okay,